Hello, I'm Goran Radevski and I'll present multimodal distillation for egocentric action recognition. The focal point of our paper are egocentric actions, which are described by hand-object interactions. These take place in cluttered environments where it's difficult to distinguish the objects which are specific to the action. Also, these videos are taken from a first-person perspective, so there is inevitably some motion blur involved. What helps to deal with these issues is explicitly representing hand-object interactions, usually via multimodal data, such as optical flow, audio, object detections, which are also employed in addition to the RGB frames. However, this will increase the memory demand and the computational complexity of the underlying model. Ideally, we want to leverage multimodal data during training, while we predict actions using only RGB frames during inference. We build a method which is based on multimodal knowledge distillation and consists of 4 parts. The first part is the teacher, which is an ensemble of all modality-specific models. Then we have the student, which is a regular RGB video understanding model. Then we have the ensemble teacher weighting module, which allows us to reweight the outputs of each teacher in the ensemble based on their performance on a held out set. And finally, we have the loss function, which allows us to balance between the task-specific and the knowledge distillation loss, and therefore allows us to get the best of both worlds. We verify to what extent we can generalize to unseen objects and environments by performing experiments on the Epic Kitchen's unseen environment split and the something else unseen object split. We see that employing additional modalities during inference will always improve the performance across datasets. This is the case where we perform inference with the teachers. We see that distilled students outperform the unimodal baseline and quite often perform even competitively with the teacher. We further see that a student which is distilled from all modalities across datasets will outperform the baseline quite significantly. Then we see that in certain scenarios, employing weak teachers in the ensemble may hurt their performance. This is the case on Epic Kitchens, where we see that the student which is distilled from all 3 modalities will perform worse than the student which is distilled from RGB frames and optical flow only. To deal with this issue, we use the ensemble teacher weighting module. On this slide, we report experiments on the Epic Kitchen's regular split, including the values of lambda and gamma. We see that models trained only on ground truth labels, or using a lambda of 0, are inferior to the distilled students, which use a lambda which is larger than 0. Using a large gamma, 30 and above, thus giving equal weights to all models in the ensemble, we will perform well despite the simple setup. We further see that training with both the task and the distillation loss, or a lambda of 0.8, will further improve the performance. Finally, we see that the best performing model will use a task and a distillation loss, or a lambda of 0.8, and will assign weights to each model in the ensemble based on a held out set performance, or using a gamma of 1. We see that lowering or increasing gamma, or the normalization temperature, to 0.33 or 3.0 will negatively affect the performance. We further study the effect multimodal knowledge distillation has on model calibration. We see that across datasets, multimodal knowledge distillation will improve the model's calibration and lower the expected calibration error. We also see that as we increase the number of modality-specific models in the ensemble teacher, this will improve the calibration of the models. We also perform efficiency analysis of multimodal knowledge distillation. We observe a higher performance of student models compared to their counterparts trained only on task labels. We see that the best performing student is competitive with the cumbersome RGB and optical flow and audio teachers on the Epic Kitchen's dataset. Lastly, we can observe that the ResNet 18 student is competitive with the computationally more expensive ResNet 50 baseline, which is trained on task labels. To conclude, in this paper, we've shown that multimodal knowledge distillation can improve the performance of video understanding models that have to use RGB frames alone during inference. In our case, this was true for both action recognition accuracy and model calibration. We've also shown an advantageous trade-off between the high performance of a cumbersome multimodal ensemble and the low computational complexity of unimodal approaches. There are some limitations to our approach. That is, we only consider the task of action recognition, while our approach can be readily applied to other tasks. Also, we've explored a limited set of modalities, while depth hand poses and motion captured by inertial sensors are available in recent large-scale datasets such as Ego4D. Please have a look at our paper by scanning this QR code.